Okay, so here is our writing chemical formula card game or card demonstration. So what the goal of this game is to balance the charges that you can see on the cards so that the overall charge of the card is going to be 0. So if I was to join two of the cards together, here I've got the formula, the element potassium, and as an ion it's K+1, and fluorine, and as an ion it's A-1. So those two cards together, +1, -1, gives me 0. So I have a K and a F, the charges add to 0, and this becomes potassium fluorine with a ratio of 1:1. And that's because one potassium ion will balance one fluorine ion to form the formula KF, potassium fluoride. If I was to join together lithium and oxygen, which is lithium is a +1, oxygen is a 2-, I'm going to need 2 lithium cards, 2 +1s to balance the 1, 2- of the oxygen. So I would write that down as 2 Li plus with a O2-, which ends up being a 2 plus a 2- gives me an overall charge of 0. And what that looks like as a formula is Li plus O will give me Li2O. Now when we write this as a chemical equation, we write a 2Li, 2 lots of those lithium ions plus 1 oxygen, we get Li2O. So this 2Li plus O giving Li2O, that gives me a ratio of 2 lithium ions to 1 oxygen ion. Alright, so now I'm going to show you if I have an ion of 2+, so in this case we have Fe2+, and it's going to combine with bromine, which is a -1. So 2+ plus a -1 doesn't balance out to 0. So what I'm going to do is I'm going to take 2 bromine ions to form my balanced formula. 2+, 2 -1s, and they will balance out. And I write this as a 2 here, and I get FeBr2. So we write the number of the number of atoms or ions that are inside the formula down the bottom here. The ionic charge is written up the top, but the actual number of atoms, so in this case we're using 2, the number of particles is written down the bottom. That shows us that the ratio in this case is a ratio of 1 to 2. 1 ion to 2 bromides. If we were to combine the ion 2+ with a sulfate ion, again we can write down Fe2+ plus SO4. This is called a polyatomic ion because there's more than one element in making up the ion, and that's a 2-. When these guys combine, they balance straight away because 2 plus and 2 minus gives us a 0. So we have up here a 0 neutral charge, and that becomes FeSO4. And our ratio here is 1 to 1. Now, the 1 in this case is talking about the polyatomic nature. This can also be described as 1 to 1 with a ratio to 4 if we talk about the iron, sulfur and oxygen elements. However, their combining ratio is 1 to 1. We talk about the ions that are being used. Now, if I was to combine ammonia, which is a +1, with a sulfate, which is a 2 minus, I'm going to need more than one of the pluses, so I'm going to need 2 of these groups. Now, ammonia and sulfate are both polyatomic. These are combined covalently, nitrogen to hydrogen. Sulfur is combined to oxygen covalently, but their electrons are not complete, so they have a charged nature to these particles. Now, this combines together like so. Now, the way we would write this is we would say NH4, 4, with a plus SO4, 2 minus, and we need 2 of those. We put a large 2 in front, and we end up with NH4. Now, this is something new. We place brackets around both of those and put the 2 down the bottom because I'm needing 2 lots of NH4 plus to balance out 1 SO4. Now, the charges have ended up balanced here because we have a 2 plus, a 2 minus, and together they equal 0. So when you come across this type of polyatomic ion, this is when we use brackets to indicate that we're using 2 of them. Okay, we'll do another example with the ammonia. If I was to connect ammonia with this ion of phosphate, we would end up with a similar arrangement as above, except now we have 3 NH4s. So we have a 3 NH4 plus PO4 3 minus, and then we have that becomes a 3 plus with a 3 minus, giving us a 0 with the charges, and we write this down as NH4. And can you guess what number I would put down there? It's going to be the 3 PO4. This is known as ammonium phosphate. Its ratio, again, can be written in terms of the elements that are present, or it can be written in terms of the ions that are present. So the ion ratio in this case is 2 to 1 for this one. In this case here it's 3 to 1. But if we were to talk about the element ratio that's present, we have 2 lots of nitrogen, 2 times 4 to give us 8 hydrogen, 1 sulfur and 4 oxygen. What I'm most concerned about is that we understand balancing the charges. Let's try one more example. So in this case, I'm going to combine tin, which is SN2 plus, with a PO3 minus. Now in this case, 2 and a 3, if I have 2 2 pluses, that's not going to balance. That's going to be a 4 plus with a 3 minus. What I'm going to have to do is I'm going to have to get myself another phosphate ion. So I now have 3 minus and 3 minus is a 6 minus, and I'll need to get myself another tin ion. So now I have 2, 4, 6 plus, and 3 minus 3 minus is 6 minus, and I end up with a balanced arrangement. So I could write that down as 3SN2 plus 2PO4 3 minus, which becomes 6 plus 6 minus, this is 2 times 3 negative, and that's 3 times 2 positive. And that gives me 0 for the charge. And when I write that down, I write SN3, no brackets required because it's a single ion, PO4, and in this case I've got 2 of them, so I need to put in my brackets 2. In this one here, we have to think of the multiples 2 and 3. What's the lowest common multiple? And in this case, the lowest common multiple of 2 and 3 is 6. And that's how I managed to get those to balance out. This tells me the ratio of tin ions, which are 2 plus in this case, to the phosphate, which is 3 minus, is I need 3 of those to balance 2 of those.